On Lesson 8, the first review problem says the picture below shows two desks views from above, whose corresponding sides are proportional. The numbers indicate the length and width of the desks in feet. Find the missing measure. What method, unit rate, equivalent fractions, cross multiplication did you use to solve the problem and why? Most people can just look at the diagram and know how big this amount is. That's what they're asking you right there. And how they do that is they basically look at the other numbers to see how they're changing. When they talk about corresponding sides, what they're saying is, so you have this smaller object right here, and here's this side, this top part. That would correspond with this top part on the other shape. Like if I would blow it up, and they would match up like they were puzzle pieces. So that's what they mean by corresponding sides. We can go ahead and use this proportion graph with this. So if you look, if I start with the if part, so if I say, well, if 2 changes to 4, that's going to go in your bottom circle. I don't have the full circle. So if 2 changes to 4, I want to know what this answer is going to be. So I'm going to pick, I want to know what x is, so I want to pick the side that corresponds with x, which would be the 4. So if 2 changes to 4, then this 4 would change to what? And if you look at how I line those up, I have this the smaller shape on the top, so the little one, and then over here I have the little shape. And you see how that matches? And then the bottom is the big shape, and the bottom over here is the big shape. So I just make sure they match. And there's a lot of ways you can solve that. You always can multiply diagonally and divide. Otherwise, you can look and say, oh, you're getting twice as big on the top to bottom, so I got to get twice as big this way. So the answer is going to be 8. Okay, the next example, it's talking about scale. And it says a scale model of a tower bridge in London shows a scale of 1 foot is to 200 feet. When you talk about scale, there's some really important things you need to know. So when they talk about scale, the first number right there is always going to be referring to the model. And the second number right there is always referring to the real or the actual size. So that's just something we need to have memorized, that whenever you see scale, the first is the model, second is the real, kind of like in the map. The first number is referring to the map distance, the second number is referring to the real distance. Okay, another thing we have to learn besides just what is scale is this word called scale factor. This is probably one of the hardest things you'll have to learn in this unit. It says, what's the scale factor that indicates how much smaller the object is than the actual bridge? So what you want to start is with what is the scale. So they want us to compare the model to the bridge. So model is the first number, so I'm going to start there with a 1, so 1 foot. Sorry about my writing. And then compare the model to the bridge. The bridge is the second number, so we're going to say 200 feet. So when you do, that's how you do scale. Scale factor is basically the same thing as finding the value of the ratio. And if you remember that from lesson 1, the value is just the top divided by the bottom. Well, if I take 1 divided by 200, I'm going to get a decimal. It's not going to be more than 1. So I'm basically just going to reduce my fraction. And it already is reduced. So my scale factor is, what that tells me is it tells me the model is 1/200th the size of the real bridge. So the scale factor always tells you how many times bigger or how many times smaller something is. So we got to do some more. Next one's, what's the scale factor that indicates how much bigger the bridge is in the model? So you see how they're saying compare the bridge to the model. So bridge is first. So the bridge number up there is 200. So that goes on top. And then compare that to the model, which is a 1. And they're both feet. So that's how the scale factor is just finding the value of that. So it's just top divided by bottom. So 200 divided by 1 is 200. Now remember, scale just tells how they're related. Scale factor tells you how much bigger or smaller something is. So this right here is 200. It's 200 times bigger. The bridge is 200 times bigger than the model. Okay, the next example, in example 2, it says find the scale factor indicating how much bigger an actual door is than how it's drawn on a blueprint. If 1 inch represents 2 feet on the blueprint. So you can see right here it's talking about the scale. So I'm going to go ahead and start with that. So it's saying how much bigger is the door than the blueprint. So when you look at this scale, you should know the second number is the real door. So we're going to start with that on top. So 2 feet. And then it says compare the door to the blueprint. So the blueprint is 1 inch. Well, if we do what we just did in the last problem, to find the scale factor, we took the top divided by the bottom. So 2 divided by 1 is 2. Which means it's 2 times bigger. The door is 2 times bigger than the picture. And if you think about that for a second, that's not going to make sense, because if you have 1 inch on your map, like that far, you're saying the door is only going to be 2 times as big, so the door is only going to be 2 inches tall. That doesn't even make sense. And the reason it's not making sense in this question is because these labels are different. So if you're ever going to do scale factor, you have to make sure the labels are the same. We don't have to have them the same on doing scale. We can have them different all the time on doing scale. We've been doing that for a while now, having them different labels. But when we do scale factor, you just have to remember they got to be the same. So I'm going to go ahead and change this top number. 2 feet is the same as 24 inches. So we can go ahead now and do the top divided by the bottom. 24 divided by 1 is 24. So the door is 24 times as big as the blueprint. That makes a lot more sense. So if you had 1 inch on your blueprint, it would be 24 inches on your door. Okay, on example 3, it says the scale on a map of Minnesota indicates that 1 centimeter represents 5 kilometers. What's the scale factor that indicates how much bigger the state of Minnesota is than it's drawn on the map? So they want us to start with the real state of Minnesota compared to the map. And when I look at my scale, I should know that the real number is the second number. So basically 5 kilometers compared to the map, the map is the first number, which is 1 centimeter. Hopefully you remember that is your scale. But what you want to do is change it so you can figure out your scale factor. Can't figure out your scale factor if the units are different. So hopefully you're remembering this metric chart. So when you make your metric chart, you put 3 blanks on each side. The kilometers over here, the millimeters is the smallest, and the centimeters is the one on the left. So basically I'm going to make both of these centimeters. So if I'm at kilometers, I'm just going to count to centimeters. So I go 1, 2, 3, 4, 5. I move my hand 5 spots to the right. So in this number 5 kilometers, I need to slide the decimal, which is at the end of the 5 spots to the right, basically having to add the 5 zeros. So that number now is 500,000 centimeters. Divided by 1 is 500,000 times as big. If you think about it, if you're looking at something, a map, and you have 1 centimeter long, you know it's a lot bigger than that. And so 500,000 times bigger does make sense. On the map of the Walt Disney World theme parks, the scale is 1 inch on the map represents 3 miles in the actual theme park. What's the actual distance between Magic Kingdom and Animal Kingdom when it's 4 inches on the map? When you have simple, these are just basically scale questions. These are much, much easier than scale factor questions because we can keep labels different, and we always know we start with our sentence that gives us our scale. So that's the sentence I'm going to underline. This is very similar to other lessons. So it says 1 inch, so we label that up, and then we says represent 3 miles. That's where your comparison is. And so then we know the labels have to match going across. And the question is, what's the real distance? Real distance is our bottom number if it's 4 inches on the map. So to solve that, we can always multiply across and divide, or multiply diagonally and divide. 3 times 4 is 12, divided by 1 is still 12. So the answer is 12 miles. Number 2 says, on the blueprint of a garage that Taylor's designing, each square has a side length of 1 inch. What's the actual width of the garage? Write and solve a proportion using this scale. So right away, a lot of times I know we're looking at the question, trying to find that thing to underline, but it's not always in the question. Sometimes it's in your diagram. So right there is our scale. So that's going to go in your if spot. So if 1 inch is 2 feet, so now you should know the labels match going across. The question is, what's the real width of the garage? Well, the real is always your second number in your scale, so that's what I don't know. We got to figure out how many inches our width is. Now, it doesn't directly say how many inches our width is, but if you count each one of these squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So 15 inches wide. We can multiply across and divide, multiply diagonally if you like. 2 times 15 is 30, divided by 1 is still 30. So the real garage is going to be 30 feet. The scale model was built for the new Target Stadium for the Minnesota Twins. The scale used for the model is 1 to 25. The height and weight of the scoreboard of the full-scale stadium is 57 feet by 101 feet. What are the dimensions of the scoreboard on the model? Okay, so basically we have this real scoreboard, and the real scoreboard is 57 feet by 101 feet. I'm just drawing a little sketch of what the real board is. But they want to make a smaller, like a model of this Twin Stadium or Target Center. So right away, you should see the scale. So right here it says the scale is 1 to 25. So we're just going to go ahead and start with 1 to 25. Now they don't have a label, and they do that on purpose because it's just saying if you look at the model, which is the first number, compared to the real, which is the second number, it's 1/25 the size. So the model will be 1 unit, the real will be 25 units, whether you're measuring it in inches, feet, yards, it doesn't really matter. So we want to figure out the dimensions of the model. And remember how the model one is always on top and the real one's always on the bottom? So I don't know the model size, that's my x. Well, when I look over at my real board, I have 2 numbers to do. This is really a 2-step question. I can just do one at a time. So I'm going to go ahead and do this number first. So this one, basically to figure out that missing number, multiply across, 57 times 1, and then you need to divide by the other number, which is 25. So go ahead and take a calculator and take 57 times 1, divide by 25, and that will be your missing number. It's 2 point something. Go ahead and calculate that. But we still have to know the other dimension. So the other dimension, I have a little one just drawn in for you. The scale obviously is still 1 to 25, right? And we're still looking for model, so we don't have the top. And the real width is 101. So what you're going to do to solve that is multiply across, so 101 times 1, divided by 25. It is 4 point, you use a calculator to find out what the rest of the answer is.